Starting with question number 1, a plank is placed on the floor with a weighty box on top of it. As shown in the diagram, a force of 70 Newton is required to lift one end of the plank while the other rests on the floor. Okay, so this is the end 1 and there is a second end. Okay, this end rest on floor. So if we apply a force on the end 1 right there, it will try to move like this, and this point will stay on, this will stay with floor. So this is basically a pivot point. Okay, so this point is taken as pivot point. So this is pivot. Okay, what we have to do, what is the weight of the plank W? Okay, what are the conditions while the other rest on the floor? Okay, so it is the condition of equilibrium. So we have to apply a principle of equilibrium, that sum of clockwise moment is equals to sum of anti-clockwise moment. Okay, so let's check the forces first. There are one force, second and third. So basically there are three forces, so there will be three moments as well. So starting with the moment of due to the force W, so it will be, this is the force and its distance from the pivot point will be this distance. This is 0.5 plus 0.5. So moment due to W is, it's W multiply by 1. 0.5 plus 0.5 gives you 1. Okay, this is basically a anti-clockwise moment, and because the force 220, the distance of the 220 from the pivot point is also is 0.5 from this point. Okay, from the pivot point to this point, so it will be 220 multiplied by 0.5. As the both the moments due to this weight and due to this 220 both are anti-clockwise, they both will be added and they will be equals to the clockwise moment. Clockwise moment is because of this 70 Newton force. Okay, so 70 Newton, this is the force, and its distance from the pivot point is this. Okay, so from this point to this point is 1, then 0.5, 0.5. The total distance is 1 plus 0.5 plus 0.5, that will be 2. So this will be 70 multiplied by 2. Okay, so this is the equation. So solving this equation, we get this will be 70 into 2 is 140 is equals to W plus 220 into 0.5, it is 110. So W is equals to 140 minus 110, that will give you 30 Newton. So it's option D. In question 2, a uniform beam is pivoted at one end and suspended by the 200 Newton force as shown in the diagram. The beam is equilibrium. So whenever the beam is in equilibrium, we can apply a principle of moment. So there are, how many forces are there? There is force due to weight and this force. So two forces, there will be two moments. Okay, so as the beam is uniform, total length is 3. So this is exactly in the middle. So from this point to this point, this distance will be 3 divided by 2, that will be 1.5 meter. Okay, so this is at the pivot point is there. This will be a clockwise movement, and due to this it will be a anti-clockwise movement. So clockwise movement must be equals to anti-clockwise movement. So moment due to this clockwise movement is equals to clockwise movement is equals to anti-clockwise. So clockwise movement is W is the weight multiplied by its distance from the pivot point, and anti-clockwise is 200 is the force multiplied by 0.5 is the distance. Okay, so weight will be 200 multiplied by 0.5 divided by 1.5. Okay, let's solve them. 0.5 multiplied by 200 gives you 100, and 100 divided by 1.5 gives you 66.66 Newton. So it's option A. Question 3. A cardboard rectangle is hung from a nail. As shown in the diagram, a plumb line is also hung from the nail. Which of the point label shows the center of gravity of the cupboard rectangle? Okay, it's a rectangular shape object, so it's a symmetrical object basically. So the center of weight should lie at the middle. So this is the correct option. Okay, so C seems. Question 4. A uniform beam of wood of mass M rests on a pivot. The far left side of the wood is tied to a bolt in the floor with a length of rope with tension T. Okay, so let's make the diagram. First of all, we have a beam. Okay, we have a beam, and let's read the statement and make the diagram side by side. A uniform beam of wood of mass M rests on a pivot. So its mass is M. So as it is a uniform rod, so its mass, its weight will act at the middle. So let's suppose this is the middle. There will be its weight. Okay, the weight is mass times gravity. It's capital M into G. Okay, so let's see the next. The far left side of the wood is tied to the bolt in the floor with the length of rope with a tension T. Okay, this is the far left side, and there is some rope, and let's suppose there is bolt. So this rope will provide a force downward direction. This force is tension T. Okay, so an object, and that lies completely where it's mean it is stable, it's in equilibrium. An object of mass M is placed on with its center of gravity on the very end of the right side of the beam. Okay, so we have to place a object M, it's small m, on the right side, so it will exert a force that will be its weight, it's small m into G. Okay, the perpendicular distance from the rope to the pivot is 1/4 of the beam. Okay, so the pivot is 1/4 length away from the rope. So let's suppose this was the middle. Let's this is the total length. Let's suppose this is the total length of the beam. Okay, and the quarter will be, and this is the half, because weight is exactly at the middle, L by 2. Okay, and pivot will be at the quarter, so there is pivot somewhere. Okay, let's suppose the pivot is at this point. So the distance from the pivot to the rope is quarter of the length. So this is the given information. Okay, so we have to find the equation relation for the mass M. Okay, so as the rod is in equilibrium, we have to apply a principle of movement. Sum of clockwise movements is equals to sum of anti-clockwise clockwise movements. Okay, so this is clockwise, this is also clockwise, and this will produce a anti-clockwise movement. Okay, so solving for the first one, solving for this force is mg, and its distance from this is the pivot point. We always take the distance from the pivot point. Okay, so we have to consider this distance. So this total distance is 3 by 4th of the total length. Okay, because let's suppose this total distance can be written as L minus L by 4. Okay, if we minus this left side, we get this distance. Okay, I have subtracted this thing from this, so this will give you 3L by 4. Okay, so the clockwise movement, this one will be mg into 3L by 4, and for this movement the force is capital M into G, and the distance from the pivot to this point, as the left side, as this side is L by 4 and it's at the center, so it will also be L by 4. Okay, so these are the two clockwise movement, and the anti-clockwise movement will be force is T, and the distance between the pivot and this tension is L by 4, so T into L by 4. Okay, so these are the three moments. So let's write it down in the equation. Sum of clockwise movement will be mg into L by 4 plus small mg 3L by 4 is equals to clockwise T into L by 4. Okay, simplifying the equation, what we get, mg L by 4 plus mg 3L by 4 is equals to TL by 4. We can take L by 4 common. On the left hand side we will left with mg plus 3mg is equals to L by 4t. Okay, I have taken the L by 4 common on the right side as well, so this will be cancelled out. We get mg plus 3 small m and g is equals to t. What we need m. Okay, so this will go on the right side, so it will be mg is equals to t minus 3mg. Now we have to take this g on the left side, this is multiplied on the left, it will be divided on the right hand side. Okay, so it will be divided by g. It can be written as t divided by g minus 3mg divided by g. This g will cancel out, this will be t by g minus 3m. Okay, so this is the equation, so it's option A. A is the right option. Question 5, we have a V-shaped object has a sphere attached with two ends. These are the two spheres attached with it. The length of the short arm of the object is L1, this length is given, and the height is also given, and we have a distance between them. Okay, we have to find the equation for D2. Okay, so what is the trick in this question? And this is balanced basically, so if it is balanced, so we have to use the same equation, clockwise movement is equals to anti-clockwise movement. Okay, so if there are two forces, two masses, so there will be two forces as well. This is the weight of m2g, and due to this mass there is a force that will be m1g, that is equals to their weights. Okay, and this is the pivot point because this is touching the ground. Okay, this is the pivot point. So for finding the moments, this force, this will produce a clockwise movement, and this will produce a anti-clockwise movement. Okay, so for movement, we always need a perpendicular distance between the pivot and the force. So let's suppose this is the line of action of force and this is the pivot. We need this distance. This is given for this case, it's d2. For this case, the force is line of action of force this, pivot point there. We need this distance, but this is not given. Okay, so first of all we have to identify this distance. So let's write it down. The distance for this, okay, I need this distance. Let's call it d1. Okay, if you see, this is a triangle. Okay, let me make it clear. This is a triangle. Okay, this is a triangle whose side, this is h1, this is l1, and this is d1 that we have to find. Okay, and the given option a, b, c, d are in the form of l1 and h1, so I have to define d1 in form of h1 and l1. So using Pythagoras theorem, I can write it as L1 square is equals to H1 square plus D1 square. So D1 square, sorry, D1 is equals to under root H1 square, it's sorry, L1 square minus H1 square. Okay, so D1 can be defined as, so let's write down the clockwise movement. Clockwise movement is equals to anti-clock. Anti-clockwise movement. Clockwise movement was this one. Force is m2g, the weight of that, and the distance is t2. And the anti-clockwise force is m1g, and the distance is d1, and d1 is defined here, that is l1 square minus h1 square. Okay, so what we need, this g is cancelled by this, we need d2, so m2 will go on the right side, it will be divided, so d2 will be m1 under root l1 square minus h1 square divided by m2. So it's option B. Okay, in this question, a man uses a metal bar to remove an iron nail from the piece of wood. The man applies a force of 150 newton at a distance of this. What we have to find, we have to find the moment. Okay, we have a force and we have a perpendicular distance between the pivot and the force. Okay, simply we have to multiply them. It will be 150 multiplied by 0.5, that will be 75 newton meter. The force applied by the man produced a turning effect over the pivot. Describe another example of using the turning effect of force. You can take example of a door. Okay, a man tries to use the metal bar to remove another nail from the piece of wood. He applies the same force of 150 newton at the distance of this. The turning effect produces not enough to remove the nail. Describe how the man can increase the turning effect by keeping the force constant. The moment depends on the two factors. One is the force and one is the distance from the pivot point. So we can increase distance of force from pivot point. Question 2. A lamp is attached to the wall. Calculate the movement of the lamp about the pivot. Okay, so we have a force, we have a pivot point, and we have a perpendicular distance between them. So we just need to convert this. It's 90 centimeters, so it will be 90 divided by 100. This will be 0.9 meter, and the force is given, so it will be moment is 25 into 0.9. That will be, let me calculate, 925 5 multiplied by 0.9, it will be 22.5 Newton meter. And question 3a shows a metal triangle suspended from a thread. Complete the sentence. Choose the correct word or phrase from the box. The metal triangle will come to rest with its center of gravity directly below the point of suspension. Okay, a student finds the center of gravity of a shape made of thin card, shows the equipment. Okay, so these are the options A, B, C, D. We have to complete this flow chart. A small hole is made near one edge of the card. After that, what we have to do, we have to attach the pin. Then we have a line is drawn from the cardboard. Then it's option A. Then the process is repeated until that, and then we have to use option C. So this is the sequence B, A, D, C. You can read the question and fill the flowchart by yourself. Okay. In question 4a, shows a truck lifting a heavy load. The truck is stationary. Identify the quantities that determines the burden. Word dependent on two quantities. One is the force. Second is the distance. Okay, so it's distance and force. Time is irrelevant in work. Draw a ring around the unit for the work, that is okay. Identify the quantity that determines the power. So power depends on the energy and the time. Temperature is irrelevant. Okay, so there is a diagram given. The truck is in equilibrium. Calculate the load. Same, this will produce a clockwise movement. This will produce a anti-clockwise movement. So both should be equal. So clockwise movement will be equals to, this is the force and load. So load multiplied by 1, and this will be force 30,000 multiplied by the distance from the 1.5. They should be equal. So 30,000 into 1.5 is equals to load multiplied by 1. So load is equals to, this will give you 45,000 Newton. Okay, so this is the answer. 45000 Newton. Units are given. Question 4d. Draw a cross to indicate the center of gravity of the pile of bricks. As the pile, it's a symmetrical shape. This is the pile of brick now. It's a rectangle. So for symmetrical shape, the center of gravity is exactly at the center. So you have to make a cross there. The truck can tilt the pile of brick backward. Explain how tilting the pile of the brick backward makes the truck more stable. It will reduce the clockwise movement. Okay, so define the term movement. Movement can be defined as turning effect of force. Okay, in question 4b, a uniform seesaw is in equilibrium with a box placed on each side. The box on the left side has an anti-clockwise movement 150 and weight W. State the clockwise movement due to the box on the, okay, so you just have to state, you don't have to calculate. Okay, so force is W and weight is this, so it is force multiplied by 1.5. This is the clockwise movement. 5c, calculate the weight of the box on the right side. Okay, you have to find the weight. Clockwise movement is this and anti-clockwise is given, so 1.5 W is equals to 150. So W will be equals to 150 divided by 1.5. So it will be 150 divided by 1.5 give you 100. So it will be 100 Newton. Question 5d. The box on the left hand side of the seesaw is now removed. Explain the subsequent motion of the seesaw. If the box is removed from the left side, then it will will rotate in the clockwise direction. Okay. In this question, a tower crane has a load W as shown in the figure. The counterweight has a weight of 80,000 Newton. This acts as a distance of 5 meters from the pivot. Calculate the moment of the counterweight. Give the units. Okay, counterweight is this 80,000 Newton. Okay, and its distance is 5. So it is simply 80,000 multiplied by 5. So multiplying 80,000 with 5, 80,000 multiplied by 5 gives you 400,000. Units will be Newton meter. The tower crane balance horizontally when holding the weight. Calculate the weight. Okay, so as it is balanced, so clockwise movement, again clockwise movement is equals to anti-clockwise movement. Clockwise movement we have calculated, that is 400,000, and anti-clockwise movement will be W is the force and 8 is the, so it's force multiplied by 8. So this will be 400,000 divided by 8. So 400,000 divided by 8 will give you 50,000 Newton. So it's 50,000. The next question shows a uniform plank AB of length 2 meters suspended from two ropes X and Y. The weight of the plank is 210. The force in rope X is P. The force in rope Y is Q. State in terms of P the moment of force about B. It's about P. It's mean this is the pivot point. Okay. So we have to just state the force is P and the distance of P from the pivot is 1.5. So it's P into 1.5. In B, calculate the moment of W about P. So W is 210 and B is this. So the distance will be is 2 by 2. 2 is the total length of the rod now. So it's at the middle. So we have to take the half length. 2 by 2 it's 1. Okay. So W into 1, that will be 210. 210 is the 210 Newton meter. 210 Newton meter. The force P we have to calculate. So to find the force P, the rod is balanced. So there is, again we will use the clockwise movement. So this is anti-clockwise, and this one will produce a clockwise movement. They both will be equal. Clockwise movement is P into 1.5. That is P into 1.5. Anti-clockwise is 210. So P is 210 divided by 1.5. So it will be 210 divided by 1.5 give you 140. And we have to find force Q. So if you want to find force Q, you have to choose, as the Q was the pivot point before at point B. So we have to choose another pivot point. There are two ropes with which the rod is suspended. One is Q and one is P. So we can choose any one of them as a pivot point. So we will take P as pivot. This is pivot now. And we have to find Q. So this will be, Q will produce a anti-clock movement now, and this will produce clockwise movement. Okay, so solving this, it will be anti-clockwise movement will be Q multiplied by 1.5, and clockwise will be 210 into, this will be, if this is 1, let me make it clear. This is half of the length of the rod, that is 1. Okay, full length is 2, half is 1, and minus subtracting 0.5 from 1, we are left with 0.5. Okay, so P into 0.5, sorry, W into 0.5, that is W into 0.5, and for this one Q into 1.5 is equals to Q into 1.5. W is 210 into 0.5 is equals to Q into 1.5. So Q will be 210 multiplied by 0.5 divided by 1.5. So solving them, we get 210 multiplied by 0.5 divided by 1.5, that will be 70. That is 70 newtons. Okay. And the next question shows a tractor fitted with a device for breaking up soil in a field. The tractor has a heavy weight at the front. Explain why the weight is needed. It's for to balance. Okay, it is used to balance tractor. Represent the weight of the device and its distance from the pivot. Calculate the moment of the weight. Okay, we have to find moment. So moment is simply its force, that is 6,000 multiplied by distance from the pivot 2.1. So 6,000 multiplied by 2.1, it will be 12600 Newton meter. And the next question shows a tractor fitted with narrow tire and the same tractor fitted with a wider tires. Explain why wide tire are more suitable for tractor on the soft soil. Okay, so it is increasing the area of tires, decrease the pressure on soil. They can easily move on muddy surface. Okay. In 4A, in a double-decker bus, there are two passenger compartments, one above the other. Shows a double-decker bus. The platform is used to test the stability. The angle the bus makes with the horizontal is gradually increased until the bus begins to topple to the left. Explain why the bus began to topple. Achha, the center of weight is at this point. Okay, as long as this center of weight is acting through its baseline, this is the baseline, the bus will remain stable. But when this will cross this baseline, it will be topple on the second side. So we can say that the weight center of gravity is not passing through baseline. There are 30 passengers in the upper compartment of the bus and 2 passengers in the bottom compartment of the bus. State how this affects the stability of the bus and the reason for this. Okay, there are more passengers in the upper compartment, so, and less in the lower compartment. So more mass in upper compartment will raise the center of gravity of bus, make it more unstable. Okay, for stability we have to lower the center of gravity, so more mass should be toward the lower compartment. In the question 4C, a bus is traveling along a straight road. The bus and the driver have a combined mass of this. when the when there are no passengers in it, the bus has 73 passengers. The average mass of each passenger is 65 kg. Calculate the total mass of the bus, the driver, and the 73. Okay. So first of all, let's calculate the mass of the passengers. 65 is weight of mass of each passenger, and there are 73 passengers. So mass of passengers is 65 multiplied by 73. Okay, and the mass of the bus is 16,000. Okay, so that will give you a total mass. So let's calculate it. 65 multiplied by 73 plus 16000, that will 20745 kg. The fully loaded bus accelerates uniformly from rest to this speed. The time taken to reach this speed 14 is 20. Calculate the resultant force on the bus. Okay, so force is ma, and ma is basically final velocity minus initial velocity divided by time. So mass we have calculated 20745, and final velocity, the fully loaded bus accelerated uniformly from the rest. So initial was 0, final is 14, initial is 0, time is 20. Okay, so it will be 20745 multiplied by 14 and divided by 20, that will be 14521.5 Newton. So it's 14521.5 Newton. It can be written as approximately 15000 Newton. Okay, 1500 approximately. 5a, a university student is constructing some flat pack furniture. Allen key has a hexagonal end and is used to tighten the hexagonal bolt. An Allen key can be used for the, okay, what we have to do, state which orientation A or B will allow the bolt to be tightened more easily. Explain why referring the moment. Okay, basically this is the pivot point. Okay, and you will apply a force at this point. So if this is the line of action of force, this is the pivot point, the moment will be the distance between, perpendicular distance between both of them. This is the distance in this case. And if you take this example, this is pivot, this is force, and the distance will be from this point to this point, d2. Okay, so as d2 is greater than d1, okay, or you can say that db, okay, because da, so db is greater than da, so in what you can say, in b, more movement will be produced, more movement will be produced. So we can easily open, so it is easy to tighten the bolt in that form. Question 5b, the dimension of Allen key are shown in the figure. The student building the furniture applies this force 150. Calculate the moment. Okay, so moment is, this is the pivot point, this is the force, so this distance will be considered. Its force is 150, distance is 1 centimeter. Okay, so 1 into 1 centimeter is equals to 1 divided by 100 meters. It's 0.01 meter, so it's 0.01 meter. Okay, so this will give you 1.5. Calculate the moment when the Allen key is in orientation B. So orientation B was this one. So this is the distance. So this is the greater side. There it is given. It's 43. Okay. So 44.3. Sorry, 4.3 centimeter. First you have to convert into meters. So 4.3 divided by 100. Okay, 4.3 4.3 divided by 100 will give you 0.043. So it's 150 into 0.043 multiply by 150, it's 6.45 Newton meter. In the question 5C, the student constructs the furniture but realizes they need to lift it up to place a rug underneath. Okay, this is the whole combination that they have given. We have a force. This is the pivot point. Okay, there's a pivot point and there is a force Fa, and this Fa is 30% of the weight. So first of all, let's calculate the Fa. So Fa is equals to 30% of 800. So that will be equals to 30 into 800 divided by 100. Okay, so this will be, let me calculate it, it's 800 multiplied by 30 divided by 100, it will be 240 Newton. Okay, this is Fa. So let's focus on this. We have to, what we have to find, we have to find Fb. So this is the main part of the figure that you have to focus on. This is Fa is basically, it's calculated, it's 240 Newton. Okay, so if this is the pivot point that we have, this is the pivot point and forces, this will produce a anti-clock movement and this will produce a clockwise movement. So anti-clock movement must be equals to clockwise movement. That is a condition to balance it. Okay, so what we need to lift the furniture. So first of all, we will calculate the balance condition. Then we know that that is the minimum force that is required to balance. If we apply a force greater than that, that can lift the furniture. Okay, so we have to find Fa. So anti-clockwise movement force is Fa multiplied with distance is 0.20 and clockwise movement force is Fb, distance is 0.80. Okay, Fa we have calculated 240 into 0.20 is equals to Fb into 0.80. So Fb is equals to 240 into 0.20 divided by 0.80. Okay, so let's calculate it. It's 240 multiply by 0.20 divided by 0.8, it's 60. So Fb is 60 Newton. Okay, it's 60 Newton. So Fb, what was the question? Calculate the minimum force Fb the student must exert to lift the, okay, so force should be greater than 60 Newton. Okay, because 60 Newton is to balance, or any force greater than 60 Newton can lift the furniture. Okay, in 5D, the calculation part C, neglect the weight of the plank of the wood. Assuming the plank of the wood has evenly distributed mass, explain how this would affect the size of the force that the student must exert to lift the furniture. Okay, and what we have done, we have neglected the weight of the plank. Okay, so if there is a weight of plank as well, so if you see, the plank is a uniform object, so its middle is somewhere at this point, so weight will also act at this point if we consider the weight of the plank. Okay, in the first case that we have solved, we have neglected that. So if there is a weight of plank as well, then what will happen, it will support us because FP was a force to lift it, and we have a force of weight as well, so it will be easier for you to lift the furniture, okay, because the weight is also acting on the right side of the pivot point in the downward direction, so it will also produce a clockwise movement, okay. So the answer will be the calculation, um assuming the plank as we have to explain, okay. So the weight of plank will also produce clockwise movement, and less force, that was FP, was required to lift furniture, okay. Okay, four objects are shown below, each is acted by the forces which one of in the equilibrium, okay. So equilibrium have two conditions: forces must be balance, first is this, and second is movement must be balance. Movement must be balance. So if you see, this is not the case, forces are not balanced. In this case, forces are balanced and movements are also balanced. In this case, the forces are balanced, but it will produce a clockwise and it will produce anti-clockwise, so both are in the same direction. So movements are not balanced, they are in the same, so it will start rotating. So these are not the options, the B is the correct one, okay. In question 2, for cubides are shown in the diagram, the position of their center of mass is shown in the figure, which of the cubide is the most stable. So we have to see, these are the center of gravity. In the figure where the center of gravity is close to the ground, it's more stable, so it's option C. A triangle with uniform density is suspended from a thread. Which diagram shows a system which is not in equilibrium? So which is not in the equilibrium? This is, I said, for the equilibrium, the center of gravity of the object should be below the thread, okay. So this is here, it's also below thread, but in this case it's on the right side, okay. So this is not in equilibrium. A, B, C are in the equilibrium. Question 4, a woman using a screwdriver to prise the lid of a cylindrical tub of paint, which row state how she would increase the movement applied by the greatest amount. Okay, what she can do is she can use a type of screwdriver with a longer length, and force applied should be double, so it's double and longer length, it's C, okay. And in a classroom, a uniform beam with a pivot as its center has a 15